This is section 3.5, solving equations and inequalities with absolute values. We will be looking at solving absolute value equations and inequalities. The goal is to write an equivalent equation or inequality that does not have absolute values. Okay, you always want to get rid of the absolute values. Don't start solving until you've made the absolute value bars disappear. Remember, absolute values can never be negative. Absolute value measures distance away from zero. When moving away from zero on the number line, you can move left or you can move right. Keep that in mind. Students always forget to move to the left, which means they've lost half their solutions. We will establish the general procedures for solving absolute value equations and inequalities before doing examples. In the discussion that follows, I'm going to let p equal a positive number. I'm going to let capital X equal a variable expression like 3x minus 17. We only really have three cases to look at: the equal, the less than, and the greater than. So the first one, absolute value equations. Okay, the form is the absolute value of capital X is equal to p. In words, this means to be exactly p units away from zero on the number line. Remember, you can go to the left, you can go to the right. So graphically, we have this. Okay, here's 0. I'm p units away on the right, I'm p units away on the left. Notice it's negative p and positive p. So when we get rid of the absolute values, absolute value of x equal p is equivalent to solving the two equations, x equals negative p or x equals positive p. Okay, you will get two different answers. The technique for solving the two equations will be the same, but you will get two different answers. Classically, one positive, one negative, but it doesn't have to be that way. And also classically, one is a fraction and one isn't. Okay, again, before doing examples, let's go to our next setup. The absolute value less than or equal to. The important part is the less than. The form is absolute value of capital X less than p, or you could have less than or equal to p. So in words, this means to be less than p units away from zero on the number line. So it is like having a dog on a leash. The dog cannot move any further away from you than the length of the leash. So if you're on the sidewalk, the dog is just moving up and down the sidewalk. Graphically, it looks like this. Okay, we're stuck between negative p and positive p. So everything in red is within p units of 0. So we get an interval. So absolute value of x less than p is equivalent to the three-sided inequality negative p less than capital X less than positive p. Similarly for the less than or equal to. Both of these would then become less than or equal to. Notice it is an interval. Okay, the absolute value less than leads to an interval. Okay, one more possibility. The absolute value greater than or equal to. Okay, the form is absolute value of x greater than p or greater than or equal to p. In words, this means to be more than p units away from zero on the number line. It's like having a fence around your house. People cannot come inside the fence. So it's kind of like they're away from you on the left, they're away from you on the right. Graphically, we have something that looks like this. We're more than p units away from zero on the right. We're more than p units away from zero on the left. Notice it is two separate intervals. Okay, they would be joined by the union. You cannot patch them up to make one inequality. Notice this one is x is less than negative p, and this one is x is greater than positive p. So absolute value of x greater than p is equivalent to solving the disjunction x less than negative p or x greater than positive p. Notice this one, the direction changed and the sign changed. You will get two separate intervals. Okay, similarly if you have the greater than or equal to up here, this would be less than or equal to, this would be greater than or equal to. So remember, the absolute value greater than leads to two separate intervals. You cannot put them together. Warning. When solving absolute value equations and inequalities, in order to apply the above methods, you must first isolate the absolute value expression. So the absolute value expression has to be all by itself before you start applying the above procedures. Let's try some examples. Want to solve for x, simplify your answers. Do not use mixed number decimals in your answers. You do not need to use interval notation. However, if you do, you must use it correctly. Now, of course, with the equals, it doesn't make sense to use interval notation. So here's our first one. Absolute value of 3x minus 4 minus 8 is equal to 12. You can notice the minus 8 is outside the absolute values. So first, you got to isolate the absolute value. So that means we need to add 8 to both sides. So I've got an absolute value of 3x minus 4 is equal to 20. You can remember when we write without the absolute values, we have two equations. 3x minus 4 equals negative 20, or that's the left side of 0, or on the right side of 0, 3x minus 4 is equal to positive 20. Okay, notice they're both going to solve the same way. You're going to add 4 and divide by 3. So if we do it to the one on the left, okay, add 4, 3x is negative 16, divide by 3, x is negative 16 thirds. Now do the equals on the right. I have add 4 again, 3x is equal to 24, divide by 3, x is equal to 8. Okay, this is the classic solution. One is positive, one is negative, one is a fraction, one isn't. So our answers are negative 16 thirds and 8. Don't put them in parentheses, don't put any decorations around them. It's two separate numbers. And again, if you put the comma in my math lab, be sure it's between the two numbers. It's not up in the numerator, it's not in the denominator. It's literally between the two numbers. Number 2. Absolute value of 7x plus 3 all over 4 is equal to 9. Our absolute value is isolated, so we're going to get two equations. On the left side of 0, I have 7x plus 3 all over 4 is negative 9. Or on the right side of 0, 7x plus 3 all over 4 is equal to positive 9. Okay, for both of them I want to make the fraction go away. My LCD is 4, so I'm going to multiply both sides of both equations by 4. I'll get 7x plus 3 equals negative 36. Subtracting the 3, I get 7x equal to negative 39. Dividing by the 7, I get x is equal to negative 39 over 7. Now let's do the same thing to the other equation. Again, multiply by 4. 7x plus 3 is equal to 36. Subtract the 3, 7x is equal to 33. Divide by 7, x is equal to 33 over 7. Okay, let's put them closer together. Let's clean it up a little bit. Okay, again, when you put the comma, be sure you are between the two fractions. In my math lab, watch where your cursor is. Also in D2L, watch where your cursor is. Number 3. I have the absolute value of 7 minus 2x plus 3 is less than or equal to 12. Okay, the first thing I need to do is I need to isolate the absolute value. So let me subtract this 3 from both sides. So I'll have absolute value of 7 minus 2x is less than or equal to 9. Okay, I have the absolute value less than. Remember, the absolute value less than becomes a three-sided inequality. The expression inside the absolute values, the 7 minus 2x, gets trapped between negative and positive of that. So I'm going to have negative 9 less than or equal to 7 minus 2x, which is less than or equal to 9. So we're trying to solve a three-sided inequality. Remember, we want to trap x in the middle. So I need to subtract 7 from all three sides. So I have negative 16 is less than or equal to negative 2x, which is less than or equal to 2. Now to get x by itself, I need to divide everybody by negative 2. Notice I'm going to be dividing by a negative number, so both inequalities change direction. So divide everybody by negative 2, and I will get 8 is greater than or equal to x, which is greater than or equal to negative 1. We were told you didn't have to write interval notation, so you can leave it. But if you did write interval notation, remember, smaller number on the left, so it would be the closed interval from negative 1 to 8. Number 4. Absolute value of 4x plus 5 all over 3 is less than 10. Okay, the absolute value is isolated. So I'm going to have negative 10 is less than 4x plus 5 over 3, which is less than 10. Remember, the absolute value less than becomes a three-sided inequality. Okay, my LCD is 3. Multiply all three sides by 3. We get negative 30 is less than 4x plus 5, which is less than 30. Okay, to trap x in the middle, subtract 5 from all three sides. So negative 35 is less than 4x, which is less than 25. Now to solve for x, divide everybody by 4. Because we're dividing by a positive number, the inequalities do not change direction. So dividing by 4, negative 35 over 4 is less than x, is less than 25 over 4. The interval would be the open interval from minus 35 over 4 to 25 over 4. Remember, if the inequalities point to the left, that's the left endpoint, that is the right endpoint. Number 5. Absolute value of 5 minus 7x greater than or equal to 10. Okay, the absolute value is isolated. I have an absolute value greater than. Remember, the absolute value greater than becomes two separate intervals. The one on the left changes that direction and changes the sign. So on the left side of 0, I would have 5 minus 7x is less than or equal to negative 10. On the right side of 0, so on the right side of 0, I'd have 5 minus 7x is greater than or equal to 10. Okay, so you're solving two separate inequalities. You get two separate intervals. Okay, let's solve the inequality on the left. Let's solve this one. So subtract 5. So negative 7x is less than or equal to negative 15. We're going to divide by negative 7, so we're dividing by a negative number. The inequality changes direction, so x would be greater than or equal to 15/7. Okay, now we solve this one. Same procedure. Subtract 5. Negative 7x is greater than or equal to 5. We're dividing by negative 7, negative number, so change the direction. X is less than or equal to negative 5/7. So there's my inequality. If you were to do the interval, it's 15/7 to infinity, union negative infinity to negative 5/7, and a bracket at the numbers, because the original problem did say it could equal. The order in which you write the intervals doesn't matter. And remember, the union symbol will be in my math lab. In D12, you're just going to type a capital U. Number 6. Absolute value of 2x minus 7 all over 5 is greater than 3. Okay, the absolute value is isolated. It's an absolute value greater than. Remember, the absolute value greater than becomes two separate intervals. So on the left side of 0, remember you change the direction of the inequality and change that sign. So I'm going to have 2x minus 7 all over 5 is less than negative 3. Or if you're on the right side of 0, 2x minus 7 all over 5 is greater than 3. Okay, both of them will solve the same way. Let's go ahead and focus on this one. Okay, common denominator is 5, so multiply both sides with inequality by 5. 2x minus 7 less than negative 15. Okay, add the 7. 2x is less than negative 8. Divide by the 2, x is less than negative 4. Now let's work on this inequality. Okay, multiply by 5. 2x minus 7 is greater than 15. Add the 7. 2x is greater than 22. Dividing by 2, I get x is greater than 11. So if I write it as inequalities, x is less than negative 4, x is greater than 11. The interval, open interval from minus infinity to minus 4, union, the open interval from 11 to infinity. We have some pathological cases. Okay, remember, absolute values can never be negative. Okay, they can never be negative. The worst they can be is 0. That means for any capital X, the absolute value of capital X is greater than or equal to 0. Now let n be any negative number. If you like, you can think of n as being negative 1. And let capital X equal any variable expression. I want to do the three things again. I want to do the equal, the less than, and the greater than, and see what happens if I have a negative number instead of a positive number. So our first one, absolute value of capital X equals n. Again, think of n as being negative 1. The absolute value is equal to negative 1. That can't ever happen. So there's no solution, since absolute values can never be negative. So your answer is going to be no solution. So warning, if you attempt to solve this the way we did the others, numbers will come out, but they will be wrong. It is up to you to notice that the right-hand side is negative. So after you get the absolute value isolated, look at the right-hand side. If it's negative and then it's equal, there is no solution. Again, that's what you write, no solution. Okay, the absolute value of capital X is less than n or less than or equal to n. Okay, absolute value less than a negative number. That can't happen. No solution, since the absolute value of x is greater than or equal to 0 for any capital X. So it cannot be less than a negative number. So once again, there's no solution. But again, warning, if you attempt to solve this the way we did the others, numbers will come out, but they will be wrong. It is up to you to notice that the right-hand side is negative. So if you isolate the absolute value and you add a negative with a less than, there's no solution. If you actually solve it the way we did the others, and you actually pay close attention to what your answer won't make any sense. And that will be your clue that you have no solution. So far, in 2 of the cases, there's no solution if the right-hand side is a negative number. We've got one more to go. Absolute value of capital X greater than n or greater than or equal to n. Okay, I want the absolute value to be greater than a negative number. That always happens. So this solution has all real numbers because the absolute value of x is greater than 0, and 0 is greater than any negative number. So this is the other extreme case. It's all real numbers, which remember is minus infinity to infinity. Now warning, if you attempt to solve this the way we did the others, numbers will come out, and of course they will work, because remember the answer is all real numbers. So the simplified form of the answer would be the phrase all real numbers, or with the integral notation, minus infinity to infinity. Again, it is up to you to notice that the right-hand side is negative. So with the absolute values and you're comparing it to a negative number, for the equal and for the less than, it's no solution. For the greater than, it's all real numbers, which are the interval from minus infinity to infinity. Let's try a few examples. Solve for x, simplify your answers, do not use mixed numbers and decimals in your answers. So the usual directions for solving. Here's our first one. Absolute value of 3x minus 12 plus 9 is equal to 4. Okay, we want to isolate the absolute value, so I got to subtract 9. So I'll have absolute value of 3x minus 12 is equal to negative 5. Okay, I notice a negative number. It says equal. This is no solution. Remember, absolute values cannot equal negative numbers. Number 2. Absolute value of 5 minus 7x over 3 is less than or equal to negative 3. Okay, no solution. The absolute value is isolated, and less than a negative number, that can't happen. Remember, absolute values are greater than or equal to 0. They can't be less than negative numbers. They cannot equal negative numbers. Number 3. Absolute value of 4x plus 7 plus 9 greater than or equal to 7. Okay, in this one, the absolute value is not isolated. So first, we have to subtract this 9. So I'll have absolute value of 4x plus 7 greater than or equal to negative 2. Okay, my absolute value is isolated. I have a negative number, and it's the greater than. Remember, the greater than, the solution is all real numbers, which has an interval that would be minus infinity to infinity. So again, remember the 3 weird cases. If you have a negative number after you've isolated the absolute value, the equal and the less than is no solution. The greater than is all real numbers. That's the end of section 3.5. It's also the end of chapter 3.